This client wants to talk to that server. It wants to get something from it. It wants some piece of information. Before it can do that, it's got to do its handshake thing, right? 3 packets, TCP SYN, SYN-ACK, ACK, and then it can go on and do whatever it was it wanted to do. Hey, give me that picture, give me that.
Things like the TCP IP.
TCP IP. Before TCP.
TCP.
The entire world seems to operate on this singular protocol. It's been anchoring the internet since the 1970s, undergoing countless iterations. TCP. Now, TCP is wonderful. It's consistent, reliable, and it's the entire reason your packets get across the globe. But is there a better way?
In the same order, without losses on the other side. And the nice thing about TCP is it also adjusts the load to network conditions. It does congestion control. But TCP is single path, right? So once you start a connection, it gets placed on a path. There's no way to move that connection on another path, and there's no way to actually move the endpoints of a connection. And this is a symptom of a problem, and the problem is that there's a mismatch between the multipath transport and the single path, the multipath networks.
Enter MPTCP or Multipath TCP. Developed and standardized around 2013, MPTCP is a massive extension on the standard TCP protocol. Its goal? To utilize multiple network connections simultaneously to provide better failover, connection stability, and resource utilization. But what does that mean in the real world? Well, let's say you have 2 connections on your computer, an Ethernet connection and a Wi-Fi connection, and you start to download a big file. Usually your operating system picks the Ethernet connection to download that file, but with MPTCP, you can put both of your connections to work at the same time. This means your files will download faster, but without MPTCP, your Ethernet connection will probably shoulder the whole responsibility of downloading that file. But raw speed is not the only thing MPTCP is good at. Let's say you're logged into your remote web server with SSH and your Wi-Fi connection suddenly drops. And now this means you have to reestablish that session, but with MPTCP, you can gracefully transfer that whole session over to your Ethernet connection without dropping a single packet. Pretty cool, huh? Wait, that's too good. This all sounds too good to be true, right? So what's the catch in all this? Well, MPTCP is a two-way street. Both endpoints have to speak MPTCP. That is, your phone or the device you're using and the web server you're requesting data from. Now, here's the problem. The vast majority of public web servers do not support MPTCP yet. But don't let that derail you. MPTCP is far from dead. In fact, if you're an iOS user, you've been using MPTCP for the last decade. On September 18th, 2013, Apple adopted MPTCP for Siri, allowing voice requests to transition from Wi-Fi to cellular data without stalling. Good, huh? Well, this brings me to my experiment. I've already run a couple of OpenMPTCPRouter experiments with my desktop setup, my spare devices and whatnot. But one day I saw my old phone, Redmi Note 7S, lying on the desk, and I had some free time on my hands. And as any Linux enthusiast with a very little amount of free time and the slightest semblance of hope, decided to do something entirely, utterly unnecessary. Backport MPTCP to Android. My old phone was already running a custom ROM Android 13 pixel experience with the kernel version 4.4. Now, to get this project working, I will have to get the legacy out of tree implementation of MPTCP and manually patch it to the 4.4 tree. But that was the easy part. That was easy enough. I did that. And after wrestling with a couple of compilation errors, I now have a fully operational MPTCP enabled smartphone capable of bonding Wi-Fi and cellular data. I actually have it right here. Um, Also, it can do the MPTCP gimmick. Wait. I don't know if you can see this. I'll attach a screenshot later. Yeah. Oh, you can see that already. Now, this is all good. This worked, obviously, because the gimmick worked. But there was one issue. When I wanted to test the combined speed of the internet connection with my VPS server, I ran into some issues. The bonding was not working. There was no bonding there. It was just using one connection and the standard TCP protocol instead of MPTCP. And that is when I realized my phone, since I used the out of tree implementation, was running MPTCP v0, and my web server, which had a newer kernel, was running MPTCP v1. Now, these two are incompatible at the protocol level. So, this was kind of doomed from the start. But that's fine, I think. This is still MPTCP enabled, and this can be done on any other smartphone if you've got the heart to do it. And yeah, that is it. That is all I wanted to say. And this was a waste of time, but a great learning experience. Bye bye.